Hello and welcome back. Okay, today I want to take a look at the bus control PCB here. Now we identified 4 problems with this. Now firstly was I had some lines that weren't connected, so I needed a couple of bodge wires. There's some strange ground pathing on here which wasn't helping us at all. The decoupling was pretty poor. A lot of that came down to just the paths between the power lines and the decoupling caps. Also, we discovered we needed to add this little bit of delay in to the clock line that was coming to bus control to make sure that it only received the clock once the outputs from the pipeline control stages was latched stably on the outputs. So in part 59 I showed some of the control edges coming off the bus control and they're pretty nasty, not very clean. So I'd like to do a respin of this board, solve all of those issues, and then we can get the scope out and do a before and after comparison of some of the memory lines that we were looking at closely then. Okay, let's see what we can do. Okay, now I think one of the big problems with this is there is this whole kind of island in the middle where there's no ground connection. So despite having a ground fill, ground kind of goes all the way around the outside in a great big loop, and I've since learnt that that's not a particularly good thing. Now, I've already fixed the non-connected points that resulted in a couple of bodge wires. Let's call this delayed clock. I would be interested to know if anyone's got a better way of doing a delay than this. The magnitude of this delay is probably overkill, but I'm not going to bump into the back of the window I need the clock to happen in with just 6 inverters, so I may as well do that. I'm not sure if the 2 spare ones I've got down here would be enough though. Now I've got an extra chip, so I need at least 1 additional capacitor. I've got 2 larger caps down here. These are 1206 instead of 0805s. I think I might be better off replacing these. Let's put 3 larger ones in. Have them 0805 so the other makers don't laugh at me. I think that's our schematic updated. I'd kind of like to keep this for posterity. The positioning and all of these demultiplexer chips seemed quite good. Just need to fit an extra inverter in. Is this 2.0 or 1.1? Let's call it 1.1 because it's not a fundamental change. Okay, it's weird. It's having a bit more trouble than I expected. But I was expecting to do quite a lot of manual routing on this regardless. And what I'm trying to do here is making sure that power and ground do what I want them to do. I won't say the other lines are irrelevant for their routing, but they're certainly a lot less important, I think, on this board. I'm pretty sure it's a mistake when it shows me briefly a design rule error. Aha, there we go. So now it realises the planes in the middle layers are VCC and ground, so it knows that all of these are actually connected up. Crazy thing is, of course, is this looks very, very similar to the original. Those internal ground and power lines make a lot of difference to the electrical characteristics and the ease of routing the lines. Okay, look at this parcel. It's huge. Makes me worry I've done something wrong with the order. But let's open it up and take a look. This is the kind of size parcel I was expecting to see. That looks good. Just picked up this parcel from the pile. This is some more of those pin headers that I'm going to need for all of these. Now let's have a look at this big bit. Oh wow. So this piece of metal feels like it's much larger than it needs to be, but that's definitely the right pattern on there. Okay, so this is obviously my first stencil. Now there might be something about the size you order these that I've selected wrong. It'll be interesting to give the solder paste a try with this. I've got the regular and low temperature stuff. Should decide which of those I'm going to use. But what actually really interested me was this. This is the board it was packed in. This looks like it must be drilling backing board from JLC PCB. There are beautiful patterns here from all the different PCBs they've made. I'm going to get set up and see what I can do to solder this. So I need to hold this securely in location. These were the first PCBs I ever had made. I had 10 of those done. I'm never going to use them all, especially since I respan it. Okay, so now I've got to line the stencil up exactly on top of here. Worth paying for the stencil just to do this. Okay, now I don't know how visible that was. That was very obvious to me when it came into alignment. Now, should I secure this at the top or at one of the sides? There's a tiny little bit of flex on the board when I push down on it, so I can see why the more experienced people kind of construct a frame, particularly when they have to do lots. Okay, the alignment's pretty good. This is the regular temperature solder paste. This is the firmly stable stuff. It seems very difficult to get the lighting right on this. Okay, apparently it's best to do this as one smooth move from beginning to end, which is never going to happen. Closer than I thought. Right, let's see how well that's come out. Okay, I can see there's some pins around here where it's not quite got enough solder on it. That's obvious when I look back. Okay, I can actually get some light back on the subject now. Giant reflective surfaces do not help. Okay, there's a couple that look imperfect, but for the most part, I think I've got a pretty good spread. That looks like I might just be missing a tiny amount of paste there. That just goes to show that the stencil is clearly the right tool for the job for applying this stuff. Let's see how that goes. Right, so that's the inverters, 74HTT04s, and these are the 138 demultiplexer chips. Now this circuit is basically lots of them. Okay, I think I may have smudged a little bit at the other end. Assess that when we get there. Got to be very, very careful with the orientation of these chips because I flip them on opposite sides of the board to make the routing easier. Okay, so I believe these pads can be quite forgiving. See if that pans out. It does occur to me that these capacitors and passives are going to go on with vastly less solder than when I hand solder them. Oh, picked that one up the wrong way around. Right, so that's just these 100 nanofarad capacitors, one for each chip. Okay, so I think they're all in the right place. So let's see what happens if we try and apply some heat. I'm afraid the microscope is going to have to take second place to the heat gun here. I have nudged this capacitor down here again. Looks like my anti-static mat isn't temperature safe. You see, that was what I wanted to see. All of a sudden snapped itself into place. Oh, that's fantastic. That felt like magic. Lots of through-hole soldering now. Okay, this burn mark is going to be there as a testament to my mistake for a long time. This technique of using free PCBs that you're not otherwise using to hold the pins is definitely good. Okay, in theory this PCB should drop on top of here. That was good. All these pins look good. Double checked all of these chips are the right way around. I think we're good to call this done. I still find it remarkable that I can design up a board like this on the PC and have it turned into a physical object in quite a short space of time. But this new technique of using the stencil and the solder paste, that felt so much easier. I mean, actually seeing all of those joints flow, assuming it works, I mean, that really did feel like magic. Particularly the capacitors have been such a pain to get on neatly. This technique was just so much easier. Okay, I think it's time to get the main build back out, plug this in and cross fingers. Okay, here we go. Now these boards look quite similar at first glance, but hopefully we're going to see a notable difference in the operation. Okay, now we shouldn't need this anymore, so this line can go directly to there. Right, let's power it up and see what happens. Okay, this is great. This has worked first time. So before we check anything else, we know we don't need this anymore, which is good because that hanging off the top was really annoying. But let's see if we can take a closer look at some of these lines on the oscilloscope and see what result we get. See if we've improved any of the other issues. Okay, so that should be the read line. That is the closest ground. Okay, this is awesome. The traces speak for themselves here. We've got much less noise and the bounce is less pronounced. We've also got rid of the bodge wires, we've got rid of the bodge breadboard, and it's all a lot neater. So I'm really happy with this. It was quite the interesting experience doing the 4-layer PCB design and the whole process of using solder paste and the stencil. I very much hope you all found this as interesting as I did. Thanks a lot for watching, and I will see you again soon. Goodbye.